Blockchain and voting. Exploring the potential for secure elections. Electronic voting or e-voting has been used in varying forms since 1970s with fundamental benefits over paper-based systems such as increased efficiency and reduced errors. However, there remain challenges to achieve widespread adoption of such systems, especially with respect to improving their resilience against potential faults. Blockchain is a disruptive technology of current era and promises to improve the overall resilience of e-voting systems. This paper presents an effort to leverage benefits of blockchain such as cryptographic foundations and transparency to achieve an effective scheme for e-voting. The proposed scheme conforms to the fundamental requirements for e-voting schemes and achieves end-to-end verifiability. The paper presents details of the proposed e-voting scheme along with its implementation using multi-chain platform. The paper presents in-depth evaluation of the scheme which successfully demonstrates its effectiveness to achieve an end-to-end verifiable e-voting scheme. Elections are a fundamental pillar of a democratic system, enabling the general public to express their views in the form of a vote. Due to their significance to our society, the election process should be transparent and reliable so as to ensure participants of its credibility. Within this context, the approach to voting has been an ever-evolving domain. This evolution is primarily driven by the efforts to make the system secure, verifiable, and transparent. In view of its significance, continuous efforts have been made to improve overall efficiency and resilience of the voting system. Electronic voting or e-voting has a profound role in this. Since its first use as punched card ballots in 1960s, e-voting systems have achieved remarkable progress with its adaptation using the internet technologies. However, e-voting systems must adhere to specific benchmark parameters so as to facilitate its widespread adoption. These parameters include anonymity of the voter, integrity of the vote, and non-repudiation, among others. Blockchain is one of the emerging technologies with strong cryptographic foundations enabling applications to leverage these abilities to achieve resilient security solutions. A blockchain resembles a data structure which maintains and shares all the transactions being executed through its genesis. It is primarily a distributed decentralized database that maintains a complete list of constantly germinating and growing data records secured from unauthorized manipulating, tampering, and revision. Blockchain allows every user to connect to the network, send new transactions to it, verify transactions, and create new blocks. Each block is assigned a cryptographic hash, which may also be treated as a fingerprint of the block, that remains valid as long as the data in the block is not altered. If any changes are made in the block, the cryptographic hash would change immediately, indicating the change in the data, which may be due to a malicious activity. Therefore, due to its strong foundations in cryptography, blockchain has been increasingly used to mitigate against unauthorized transactions across various domains. Bitcoin remains the most distinguished application of blockchain, however, researchers are keen to explore the use of blockchain technology to facilitate applications across different domains, leveraging benefits such as non-repudiation, integrity, and anonymity. In this paper, we explore the use of blockchain to facilitate e-voting applications with the ability to assure voter anonymity, vote integrity, and end-to-end verification. We believe e-voting can leverage from fundamental blockchain features such as self-cryptographic validation structure among transactions, through hashes, and public availability of distributed ledger of records. The blockchain technology can play a key role in the domain of electronic voting due to inherent nature of preserving anonymity, maintaining decentralized and publicly distributed ledger of transactions across all the nodes. This makes blockchain technology very efficient to deal with the threat of utilizing a voting token more than once and the attempt to influence the transparency of the result. The focus of our research is to investigate the key issues such as voter anonymity, vote confidentiality, and end-to-end verification. These challenges form the foundation of an efficient voting system, preserving the integrity of the voting process. In this paper, we present our efforts to explore the use of the blockchain technology to seek solutions to these challenges. In particular, our system is based on the Pred-A voter approach and uses an open-source blockchain platform, multi-chain, as the underlying technology to develop our system. In order to protect the anonymity and integrity of a vote, the system generates strong cryptographic hash for each vote transaction based on information specific to a voter. This hash is also communicated to the voter using encrypted channels to facilitate verification. E-voting background and requirements. Electronic voting has been an area of research focus for many years by using computing machines and equipment for casting votes and producing high-quality and precise results in accordance with the sentiments of the participating voters. Various attempts have been adopted in practice to support election process. Initially, computer counting system allowed the voter to cast vote on papers. Later on, those cards went through the process of scanning and tallying at every polling cell on a central server. Kadam et al. Direct recording electronic (DRE) voting systems were put in place later on, which were admired and acknowledged greatly by the voters in spite of the resistance from computer scientists. If the voting system is well understood by the voters, the system's usability can be increased remarkably. DRE systems in particular have gathered a lot of successes in bringing the voters to use this technology. These systems work more or less in the same way as any conventional election system does. In the case of DRE, a voter begins his journey by going to their polling place and get their token to vote, where he utilizes his token at the voting terminal to vote for his candidate. When the candidate selection procedure is completed, DRE systems present the final selection to the voter before actually casting it, and after the final selection, the ballot casting is completed. More recently, distributed ledger technologies such as blockchain have been used to achieve e-voting systems, primarily due to their advantages in terms of end-to-end verifiability. With properties such as anonymity, privacy protection, and non-repudiation, blockchain is a very attractive alternative to contemporary e-voting systems. The research presented in this paper also attempts to leverage these properties of blockchain to achieve an efficient e-voting system. A detailed analysis of such systems is presented in the next section, along with the identification of comparison with these approaches. E-voting requirements and compliance by the proposed system. The generic requirements for a typical e-voting system have been defined in. We present a brief description of each requirement along with an explanation of how the proposed system fulfills it. Privacy. Keeping an individual's vote secret. The system leverages cryptographic properties of blockchain to achieve privacy of a voter. More specifically, as voter is registered into the system, a voter hash is generated by blockchain, which is the unique identifier of a voter into the blockchain and is protected from misuse due to collision resistance. Property of the cryptographic hash. Due to this, the traceability of a vote is also non-trivial, thereby protecting the voter when under duress. If you find this video useful, don't forget to like and subscribe to our channel.